Hi there, mathematicians. Let's get started with slopes of lines, section 3.5. All right, our essential question is, how can we use the slope of a line to describe the line? So our objectives are that mathematicians will be able to find the slopes of lines, use slope to partition directed line segments, and identify parallel and perpendicular lines. Let's start by doing a refresh on slope. We know slope to be the ratio of the vertical change to the horizontal change of any 2 points, also called the rate of change. We use this lowercase scripted m to represent slope, and it equals the slope, which is also known as the rate of change. So it's the change in y. Our little triangle represents change. So change in y divided by change in x. So I have a little rise over run. We know this from Algebra 1. And notice I spelt it with a y. That was intentional instead of an I. And that's because the y values and coordinates are always in the numerator. So rise with a y over run. To help us remember that you do the difference of your y coordinates divided by the difference in your x coordinates. So using this formula, we can always figure out the rate of change. So here's a picture for run and rise. So we know we're running, which is the change in x, and then if we rise, that's the change in y. All right, so let's just see what we remember from Algebra 1. So take a moment, pause the video, and try to identify these slopes for line K, J, N, and L. All right, so line K has a positive slope, line J has a negative slope, line N has undefined, and line L has a 0 slope. All right, and then we have a special acronym that can help us remember the special lines that go vertical and horizontal. So for the vertical slopes, think of VUX. So vertical line is an undefined slope, and it always is an x equals equation. So VUX. And then for the horizontal, it's always going to be a 0 slope and a y equals equation, so HOI. So VUX, HOI, to help you with the special vertical and horizontal lines. All right, so let's take a look at these lines, finding the slopes of lines A, B, C, and D. So pause the video here and try to identify these slopes and actually find the value that describes the slope. So you can use your formula and plug in the coordinates on the line, or you can just do the rise over run using the grid. Okay, so for line A, your slope should have been -1. For line B, your slope is 2. For line C, your slope is 0. And for line D, it's undefined. So just to remember real quick for your fractions, you can never have 0 in the denominator. It's not possible. In fact, if you were to type this fraction in your calculator right now, go ahead and try it. Type it 4 divided by 0 in your calculator. And what do you get as a result? Well, you should have gotten an error message. And that helps us remember that these are undefined situations. So these are vertical lines. All right, here's some extra examples to find slopes from these given points. So now I'm taking the graph or the grid away. So let's see how we do with no grid and just having the coordinates. So again, you would plug in your coordinates into the formula, and labeling the x1 and the y1 would be helpful, along with the x2 and y2 labels. So we'll allow 2 to be x1, -4 to be y1, 6 will be x2, and 6 will be y2. So when we plug that into our formula, we get a result of 5/2. And simplifying your fraction is always helpful. So when you're identifying your slope of a line, make sure you completely simplify your fraction. Watch out for double signs, so this minus negative always becomes a plus. All right, let's look at the next one. And we'll have 2 and 3 for our x1, y1, and 2 and 6 for x2, y2. So we plug it into the formula, y's in the numerator and x's in the denominator. This resulted in 3 divided by 0. Remember, 0 can never be in the denominator, so we have an undefined slope. All right, so partitioning a directed line segment is a segment that represents moving from point A to point B. So partitioning, remember, is to divide into parts. We've done partitioning before. It was on a one variable direction. This time our partitioning is going to be in the coordinate plane, so 2 dimensions, so an x and a y value. So find the coordinates of point P along the directed line segment AB so that the ratio of A to P to PB is 3 to 2. So the length of AP to the length of PB is a 3 to 2 ratio. So we need to figure out where we're going to put P along this directed line segment. So it's going to be a 3 to 2 ratio. Well, here's what we need to think about. If it's 3 to 2 ratio, how many total parts is that? So if I add my 2 parts together, that's a total of 5. So I need to think of this as breaking it up into 5 total congruent pieces. So 5 total congruent pieces along the line segment from A to B. All right, so let's take a look at where we would place P along this segment AB. And if it's a total of 5 pieces, because I've added the 3 and the 2 to get my 5, I want 5 congruent pieces. Well, P is going to be 3 of those pieces, so that length is going to be 3 out of the 5 pieces. So how do I figure out where I'm going to place P on the segment AB? Well, I figure out my rise and my run, so 6 and 3. Rise is 6, run is 3. And then don't simplify that fraction, keep it as is, so 6 and 3. And we want to multiply this 3/5 times each of these values. And you can convert your 3/5 to decimal if it makes it easier. So 3/5 of 6 is 3.6. 3/5 of 3 is 1.8. So that's going to be my new rise and my new run for where P is going to be located. So I run 1.8 and I rise 3.6, which means I'm located right here for P value. For the P coordinate. Now to figure out these values, the 4.8 and the 5.6, I simply add 1.8 to the 3, which is the x value of the A coordinate, and that becomes 4.8. Then I add 3.6 to my y value, which was 2 for 0.8. I'm adding 3.6 to 2, which is a result of 5.6. So P is located at 4.8, 5.6. All right, so let's talk about the slopes of parallel lines. Slopes of parallel lines have the same rate of change. So they are the same value, in other words, equal slope. Our implied is parallel lines implies equal slopes. And we have a picture here of 2 different lines with parallel marks, a blue line and a red line. So my blue slope, we'll call it M1 for line 1, is equal to the slope of line 2. So M1 is equal to M2, therefore these lines are parallel. And switch that, and you can say if you have equal slopes, then you have parallel lines. So let's take a look at this example. What's the slope of a line parallel to line y1 equals 7x minus 4? Well, first, identify the slope of the given line. So M1 would be 7. So that means any line parallel to this line must be 7. We figured out our slope because it's in mx plus b form, so slope-intercept form. And slope is always the number, the m value, that's in front of your x variable. So if there's a number right there, that's your slope. And if you don't see a number in front of x, then it's assumed to be 1. All right, slopes of perpendicular lines are opposite reciprocals. In other words, flip the fraction and change the sign. So if I had a fraction a over b, its reciprocal would be b over a, and then opposite would be negative. So signs have to be opposites, and you flip your fraction, in other words, the reciprocal. So opposite reciprocals means that the lines are perpendicular. And you can always check perpendicular slopes by multiplying them together. So take m1 times m2, so slope 1 times slope 2, and if it equals -1, then they are perpendicular lines. So that leads us to our implied. Perpendicular lines implies slope of the first line times slope of the second line equals -1. So the product of the slopes is equal to -1. So let's check our slopes practice here in this example. We have a line y1, so what's the slope of the line that's perpendicular to this line? It's in mx plus b form, so that allows me to identify my slope. So my slope here is 3/4. So that means its opposite must be negative, and the reciprocal, if I flip it, must be 4/3. So the line perpendicular to this first line must have a slope of -4/3. And here we can see a visual of lines that are perpendicular. Alright, so pause the video here and determine which of the lines are parallel and which of the lines are perpendicular. Again, parallel lines should have the same slope, and then perpendicular lines should have opposite reciprocal slopes. So pause the video here and try to see which lines are parallel and which lines are perpendicular. Alright, so let's do a quick check. Line A's slope is 1/3. Line B's slope is 1/2. Line C's slope is 1/2. Line D has a slope of -2. So right now I can conclude that line B and line C have the same slope, therefore line B is parallel to line C. And line D is an opposite reciprocal of line B and C. So line D is perpendicular to both lines B and C. And looks like line A has no direct relationship, neither parallel nor perpendicular, to any of the other lines. Alright, let's do a quick practice with some extra examples. So here we have, if m equals 2/7, what is parallel slope to this given? So parallel slope, remember, are equal, so it should be 2/7. So what would be the perpendicular slope to this given slope? We would do opposite, so it would be negative, and flip, so 7/2. Next, if the slope is 1, then what's the perpendicular slope? So we flip, so it's 1, and opposite would be negative. So it's -1. Next, our y1 equal to 1/2 x plus 4, and y2 equal to -2x plus 6, parallel, perpendicular, or neither. So line 1 and line 2. How would we classify them? Well, the slope of y1 is 1/2. The slope of y2 is -2. So if we compare the slopes, they appear to be perpendicular. Because they multiply to be -1, then the lines are perpendicular. And then as far as our special lines, the vertical and the horizontals, so Vux Hoi, anytime we have slopes, vertical slopes are always going to be parallel. Horizontal slopes are also going to be parallel. So that means they both have a 0 for the horizontal, so a horizontal line is parallel to a horizontal line, so that means they both have a 0 slope. And same is true for the verticals, they both have undefined slopes. And then a horizontal line and a vertical line are always going to be perpendicular. So a 0 slope is perpendicular to an undefined slope. All right, that's all for this lesson. Bring in clarifying questions and be ready to practice these skills. See you in class.